so far we've seen linear regression with one continuous x variable, but x doesn't have to be continuous or near continuous. We now consider linear regression with one indicator variable that just distinguishes between 0 and 1, right? So x is 0 or 1. And this is useful because it results into the so-called two-mean model. We had seen the one-mean model at the very beginning where I said for the housing prices, y equals mu plus error, and that's one mean, and now we get into two means. So why might this be useful? Well, for example, we might want to understand the variation of birth rate because low birth rate may lead to death. And specifically, so birth rate is a health indicator. So specifically, we're interested to finding out what the probability is of between having less than 5 pounds birth weight, because that's an indicator that the baby needs to go into intensive care right away. And we can compute that by getting mu and sigma from the normal distributions. So do we need a one-mean model, just one mean for all the babies? Or are the boys heavier than the girls, or vice versa? And do we need a two-mean model? So two-mean would be, if I have two of these equations, yj equals mu j plus epsilon, where j has an index 1 or 2, and there's one separate for boys and one for girls. It is easier to put that same problem into a single equation, and I'm going to reparameterize it as follows. Y equals mu1 plus delta x plus epsilon and blah, blah, blah. Where x only takes two values, 0 and 1. And for sake of argument, we'll say x for 0 equals 0 for baby girls and x equals 1 for baby boys. It doesn't matter which way around. You just have to interpret the estimated coefficients based on your definition, how you define it. So using this definition that I have here, x equals 0 for baby girls, delta times 0. So that means that the mean for baby girls is mu1, and for baby boys it's mu1 plus 1 times delta, so mu1 plus delta. That's based on this definition. So that is the two-mean model that we have described here, because there are two means, one for boys, one for girls. But we can also rewrite this, and you'll see that this is just regular regression, linear regression. Because mu1 takes the role of beta 0 and delta takes the role of beta 1. We have never made any assumptions on x, so this is completely legitimate, whether it's continuous or not continuous. And the name, whether it's mu, delta, or beta 0, beta 1, doesn't matter, right? So this is an example that you can fit with a linear regression model. That is the end of this section.